Hey, this is Leach with Simpson Math, and in this video, I'm going to talk about the tangent half-angle identity. We have a lecture video up all about the half-angle identities, but the simplification process is a little bit tricky with these half-angles, and specifically with the tangent because there's three different versions. So I'm going to take this same problem of tangent 7 pi eighths, and I'm going to simplify it, or I'm going to evaluate it using all three versions of the tangent half-angle identity, as well as show you different options along the way while you work those problems. My goal in this video is to give you a few more tools in your toolkit or arrows in your quiver that you can use to evaluate these problems for this particular lecture, for this particular concept, plus going forward. These evaluating with square roots and fraction and all that. These are just some fundamental skills that you need to know. So let's get started. So we have we're going to be evaluating tangent of 7 pi eighths, and like I said, we're going to be doing the half-angle identity. So we need to make sure we know what theta is being halved with 7/8. So looking at our 7/8, you can think to yourself, okay, well, that's either going to be 7 pi fourths that's getting halved or 7 pi sixteenths. And to be honest, sometimes I don't remember. So just try it and see and simplify it and see if it's right. So if we have 7 pi fourths and we divide that by 2, so we halving 7 pi fourths. Dividing by 2 is the same thing as multiplying by 1/2. So multiply by 1/2. And we have 7 pi times 1 for 7 pi in the numerator, and 4 times 2 for 8 in the denominator. So 4 is the correct choice. If you thought that this was 16, then this would have been multiply 32, and that would have been wrong in the wrong direction. So if you're ever not unsure, try it and check it, and then move on. So our theta, all of these thetas are going to then be our 7 pi fourths. But remember, the angle that we're evaluating tangent at this entire thing, this entire pi halves, is 7 pi eighths. Oh, one more, just another way, just more mathematical way to do it. If 7 pi eighths is theta over 2, then what you could do is multiply both sides by 2. Those 2 and the 8 reduce to 4, and that's how you get 7 pi fourths. That's a more algebraic way than just guessing and checking. All right, so we have 7 pi fourths that's getting halved. So we're going to plug in 7 pi fourths into all of our thetas. I'm going to be doing first this one. I'll eventually do all of them. So this video will be a little bit redundant at some point, but I'm just working through this first one. So I'm going to replace theta with 7 pi fourths. So we have plus or minus the square root of 1 minus cosine of 7 pi fourths over 1 plus cosine of 7 pi fourths. Make sure to be paying close attention to which one is positive and which one's negative. In this case, it's negative in the numerator and positive in the denominator, and that holds true across the others as well. Now, remember, the angle that we're evaluating is 7 pi eighths. 7 pi eighths is just almost pi, so it's right about here, 7 pi eighths. So 7 pi eighths is in the second quadrant, and tangent is negative in the second quadrant. So we're going to make a judicious, I can say that word right, judicious choice, and choose the negative and get rid of the plus. So all the way down, you'll see my negative is going to follow through. If for some reason it was a plus, let's say we were in the third quadrant or the first quadrant, then I wouldn't use the negative, and then we wouldn't see that symbol at all. It would just be positive. All right. So now let's evaluate cosine of 7 pi fourths. Well, 7 pi fourths is in the fourth quadrant, and in the fourth quadrant, cosine is positive there. So this is a positive square root of 2 over 2. Our reference angle is pi fourths, so that's why that's square root of 2 over 2. Like I said, I'm going to be showing you different options, different ways to simplify this. So our first kind of split is either you can simplify by doing a common denominator or multiplying by fancy 1. Let's walk through how to do this using a common denominator. All right, so we take our fraction here, negative up front, big square root, but I have these fractions here, this fraction and this 1, so I'm going to add them and get a common denominator. The denominator with the 1 is a 1, the denominator here is a 2, so the least common denominator or least common multiple is 2. So I'm going to multiply this 1 by 2 over 2 and this 1 by 2 over 2. And then we end up with this right here, with all these 2's over 2's. So I can simply add those, 2 minus square root of 2 over 2, and then now 2 plus square root of 2 over 2, right there. At this point, some of you might see, oh, those 2's can reduce. Yes, they can, and you can skip directly to that step. If it's not so obvious to you that those 2's can reduce, then just do keep, change, flip. We're going to multiply the numerator times the reciprocal of the denominator. That's what division is. When you divide by a fraction, you're really just multiplying by its reciprocal. So then now we can obviously see that those 2's reduce. So we now have a negative square root of 2 minus square root of 2 over 2 plus square root of 2. Okay? All right, so let me pick back up, let me rewind time just a bit and show you how we could have used multiply by fancy 1 here. All right, so like I said, our least common denominator between 1 and 2 is 2. That's the same for the denominator as well. So if I multiply by fancy 1, that is the least common denominator of all my denominators, I can kind of get rid of having to do the adding the fraction math. So we multiply by 2 over 2, which is just fancy 1. Make sure we distribute. So this 2 goes on to both of those terms. 1 times 2 is just our 2. And here I show that those 2's do reduce. So this 2 reduces with that 2. If this being just a regular 2 over regular 2 bothers you, you could write this as 2 over 1 over 2 over 1. That's not showing up. There we go. You can just, let me do that again. 2 over 1 over 2 over 1. You can write it like that, just to help you with the multiplication of those fractions. So this is a square root of 2 times 2, and then a 2 times a 1, and those 2's reduce, leaving us with just a square root of 2. And so notice then we end up in the same spot. So with both of these options, we end up with the same thing, a negative square root of 2 minus square root of 2 over 2 plus square root of 2. So again, I'm just giving you tools, arrows in your quiver, different things for you to be able to try to be able to work this. All right, now this is violates the square root in the denominator, or not allowing square roots in the denominators in two different ways. One, all of this is inside of a denominator under a square root. That's a no-no. Plus, we have an obvious square root in the denominator. So let's get rid of, first, this square root in the denominator. Now, if you recall about simplifying, rationalizing denominators, if I just multiply by square root of 2 over square root of 2, that would not work so well. Sure, that wouldn't work well. It wouldn't work. Because if I distribute a square root of 2 in the denominator, sure, square root of 2 times square root of 2 is just 2, but I have to distribute, and that would be 2 times square root of 2. That still has a square root. So we need to multiply by the conjugate. This should not be a new concept. We should know how to do this. We're going to multiply by the conjugate. So it's a binomial, the same terms, but the addition or subtraction symbol is flipped. So instead of 2 plus square root of 2, I'm multiplying by 2 minus square root of 2. And I'm attacking the denominator. I'm multiplying by the conjugate of the denominator, because that's the one that I'm needing to make those square roots go away. I show the full out math here. In a minute, I'll multiply by conjugate again, and I don't show the full foiling. So I do 4 in the numerator. 2 times 2 is 4, and 2 times negative square root of 2 is my negative 2 square root of 2. The negative square root of 2 times 2 is negative 2 square root of 2. And negative square root of 2 times negative square root of 2 is a positive 2. So over here, just a reminder that if you multiply a square root by itself, that ends up being square root of 4 in this case, which is then just 2. in between here, you can also see that this would be square root of 2 squared, and those squares and square root literally reduce. Those up in the exponent level, they reduce to 1, and we're left with just 2. So that's what we have going on right here. All right, when we FOIL the denominator, we end up with 2 times 2 is 4. And then we have a negative 2 square root of 2, and then a positive 2 square root of 2, which will cancel to 0. That's the beauty of multiplying by conjugates, is that this stuff right here that has the square roots, they go away. Those middle FOIL terms cancel to 0. And then again, positive square root of 2 times negative square root of 2 is a negative 2. So then we're left with, once we add everything up, I have 4 plus 2 is 6, and I have 2 negative 2 square root of 2, so that's negative 4 square root of 2, and 4 minus 2 is 2. Now, suppose that this was like a 5 or something, and nothing would reduce, then I would have to deal with this 2 again and multiply by radical square root, by square root of 2 over square root of 2 to rationalize that denominator further. But notice that 6, 4, and 2 are all even. Again, I'm not touching the square root. It's just a separate term. I can't pull out from it. So, but 6, 4, and 2, those are all even. So I can factor a 2 out of the numerator. So left hand side is a 3 minus 2 square root of 2. I just divided 2 out of both of those terms. Again, not from this term. I'm not dividing a 2 out of that. That's kind of just pretend that that's like an x. And so then here our 2's reduced to 1. And then we're left with just negative square root of, big long square root bar, 3 minus square root of 2. Sorry, 3 minus 2 square root of 2. Make sure that this square root bar is nice and long. It needs to go past the end of that square root to show that all of this is under that square root. This is fine. It's fully simplified. There's no square roots in the denominator, so we're good to go. So we have tangent of 7 pi eighths is negative square root of 3 minus 2 square root of 2. Negative square root of 3 minus 2 square root of 2. It's a better way to say that. All right, so what you kind of learned here, what I showed you is that you can multiply by common denominator. You can get a common denominator and add, or we can multiply by fancy ones. And oftentimes in my experience, multiplying by fancy ones is the more efficient way. It takes less steps. It's a lot faster, more direct way of dealing with that problem. But common denominators is not incorrect. All right. So now what if you wanted to do that middle one, the one where it's sine theta over 1 plus cosine theta? Again, be careful with the sign. This is a plus. I was prepping this a minute ago, and I worked and was finished, and I checked my answer, and I was like, wait, that's not right. And I had a minus here, I had the sign wrong. So do be careful about your signs. They can be tricky or easy to mess up. So again, it's the same problem. So it's our same thetas. So I'm going to replace my theta in my identity with the 7 pi fourths, because that is what is getting halved to give a 7 pi eighths. Sine of 7 pi fourths, well, sine is negative in the fourth quadrant, and that's where 7 pi fourths is. The reference angle would be pi fourths, so we have a negative square root of 2 over 2. And then cosine of 7 pi fourths is the positive square root of 2 over 2. All right, now we need to simplify. We have fractions, we have square roots in the denominator, we get through all of those. Let's first deal with a fraction. Again, same two options. Common denominator, fancy one. I'll move a little bit faster through this. So common denominator, turn the 1 into 2 over 2. Add them together. At this point, those 2's could reduce, and you could jump directly down to here. Or you can multiply by the reciprocal of the denominator. And then when you do, then you obviously see that those 2's reduce. And we're left with a negative square root of 2 over 2 plus square root of 2. Or you could see, okay, well, if I look at all my denominators are just 2's and 1's. So the least common multiple or denominator of 2's and 1's are 2's. So I'm going to multiply everything by 2 over 2. Again, that's just fancy one. These 2's will reduce. I will distribute. And so we now have a 2 plus, and then these 2's reduce. And so I'm left with 2 plus square root of 2. To me, that multiplying here is a little bit faster and easier. but neither are, you can do either method. All right, so now I need to rationalize. All right, I don't have a double square root issue, a double square root in the denominator issue. I just have this square root of 2 that need to be dealt with. Again, I can't just do square root of 2 over square root of 2 because it would mess up. It wouldn't get rid of the square roots, so I need to multiply by the conjugate. So the conjugate of 2 plus square root of 2 is 2 minus square root of 2. Go through that same process. Again, whenever we FOIL conjugates, those middle two terms will always cancel. At this point, with working with identities, I'm okay in my math class. If you're watching this and you're just learning, hey, but if you're my student, I'm okay if you skip at this point in the semester. So because we have 2 times 2 is 4, the other two terms are going to cancel to 0, and then square root of 2 minus 2 is 2. And also we distribute the negative square root of 2, and we have this. All right, simplify, and we now have a 2 in the denominator. We've got lots of 2's, so we can factor out a positive 2, factoring out a positive 2 just for reduction purposes. So we factor out the positive 2, keep that negative, and keep that to be a plus. 2's reduce, and we now have negative square root of 2 plus 1. Now you might be saying to yourself, Leach, we just worked this problem a second ago, and that is not the same thing. You're right, they're not written the same, but they are the same value. And I'll show you calculator output in a second, showing you that they are equivalent. All right, so there's one last method, and this one is where we're going to, not method, but we're one last identity, and it's going to be the 1 minus cosine theta over the sine theta. And I'll show you that you get the same thing. Now, before I get going on this one, just the nature of this one allows me to have a little bit more flexibility and options. And you'll see that once I do my first bit of evaluation, I actually have 3 different options of how to work that. And then once I get to this step, I actually have like 2 different options on how to work that part. So again, if you're working this problem, you don't need to do all of these. You just pick kind of one of these paths. So maybe you just do this here and here, or this one and then this one, or this one and this one, whatever makes sense to you. I'm just giving you tools, arrows in your quiver. So let's work through this first sort of kind of options. First two should be pretty familiar. It's a common denominator, fancy 1 stuff. So I need to add and get common denominator. So 2 over 2. So we change the 1 into 2 over 2. Then we add them together, and I get 2 minus square root of 2 over 2. And then you can either reduce directly, or you can do keep, change, flip, and then reduce, or do the fancy 1 stuff. So again, the common denominator, or least common denominator of all of them is 2. So multiply by 2 over 2. Again, if you can think of that as 2 over 1 over 2 over 1. 1 times 2 is 2. 2's reduce. 2's reduce. And we're left with 2 minus square root of 2 over negative square root of 2, which is the same thing. Another approach would be just to deal with this as dividing by something and then multiply by the reciprocal instead. So because dividing by fractions is the same thing as multiplying by its reciprocal. I can do that in this one because just a single term, I don't have any addition. So you can't just flip things over willy-nilly if there's a plus in the way. If there's a plus in that denominator, but in this case, there's just a single term, so I can flip that fraction, and it's all good. So let's do that. So I'm going to multiply my numerator times the reciprocal of the denominator. So I do that, I flip my denominator and multiply. And then let's distribute. So I distribute here, and then I distribute here. So I end up with negative 2 square root of 2. Negative 2 over square root of 2. Gotta get that over in there. And then square root of 2 reduces with square root of 2. And 2 reduces with this 2. And this is a negative times a negative, which is a positive. So the negatives reduce, the square root of 2 is reduced to 1, and the 2 is reduced to 1, and we're left with just a plus 1. One note about this sign thing here, because this will show up in a minute as well. Remember that if I have, let's say, a divided by negative b, that is the same thing as saying a negative a divided by b, which is the same thing as saying I have a negative times a over b. So if these are all just single terms, I don't have any pluses in the, getting in the way to confusing the matter. If I did have pluses, I would need to have parentheses around it all. But dividing by negative, or the negative in the numerator, or just the negative out front, which is this like a -1 times this, those are all equivalent statements. So this negative here in the denominator is kind of weird, and so I'm going to just pop it out front. Technically speaking, in terms of kind of being most simplified, we typically either want the negative in the numerator or the negative out front. And it's slightly mathematically awkward, but not incorrect to have the negative just hanging out in the denominator. All right, so this is not quite that same thing that we have over here. We'll see this in a second, and so you can see kind of where to pick up and finish that off, but that's how we can do with those kind of first steps. Common denominator, fancy one, or even just go ahead and keep, change, flip, and distribute. All right, so at this point, I have another set of options. We could do what we've been doing, which is rationalizing, or again, because I have this singular term in the denominator, I can unadd. I can decompose the fraction into two different bits. So let's just walk through the rationalization real fast. So here I don't need a conjugate because it's just a single square root in the denominator. I could do negative square root of 2 over negative square root of 2, but then I'd have to distribute the negative. So I'm just going to leave the negative alone and just multiply by square root of 2 over square root of 2. I distribute the square root of 2, so now I have 2 square root of 2, 2 times square root of 2, minus, and if I have a negative square root of 2 times a positive square root of 2, that's a negative 2, as we saw earlier. So I have lots of 2's. I'm going to factor a 2 out of here, here, and here. Again, I'm not touching the square root. So factor out the 2, and then these 2's can reduce. Now I still do have this negative, but again, I have this whole chunk of a term divided by now a -1. You can just express this as a negative times square root of 2 minus 1, and then just distribute that, and we have a negative square root of 2 plus 1. Or just know, dividing by negative is the same thing as dividing by -1 is the same thing as multiplying by -1. So that's how we end up with negative square root of 2 plus 1. Or you could have had the negative all along and then dealt with it, and you would have had that directly. All right, or let me show you this unadd method. So I have this fraction, and I notice, especially because I see what's going to happen here, I can't just reduce these. A lot of students want to get slash happy and be like, slash, and they want to say, oh, this is now 2 plus 1, or even worse, just 2. They want to make this go to 0. No, that's not the case. But I can unadd. Notice I have 2 over negative square root of 2 minus square root of 2 over -2. I can unadd this fraction into its original parts. Anytime you think, oh, am I allowed to do this? I break this apart. I write it 2 over negative square root of 2 minus square root of 2 over negative square root of 2. I write that, go, was that legal? Well, go backwards. They have the same denominator. So if I add them, this would be a 2 minus square root of 2 over this same thing, negative square root of 2. Yep, that's legal. So if you do something and you're not quite sure, you should be able to immediately, temporarily undo it and get the same thing. And that should give you confidence that what you just did was legal. If you try to reverse it and it's not the same, then you probably messed up in one of those directions. All right, so negative square root of 2 over negative square root of 2 reduces to 1. And we now have negative 2 over square root of 2 plus 1. Hey, that sounds familiar, right? That's what we had up here, right? So I have this same thing, so I'm just going to finish off this problem right here. So I could have gone this problem, done this KFC, and then hop down here and then finish the problem here, or done one of these methods and then be working right here. So it's all kind of intertwined. All right, so how do we finish it up from here? Now we just need to fix this square root of 2 in the denominator. So we're going to multiply by square root of 2 over square root of 2. We got to rationalize. So we have then 2 over 2, those reduce to 1. So now we have a negative. This negative is only touching this first term. It's not distributing. So it's just this first term. So negative square root of 2 plus 1, which is what we saw a second ago. So we had three different answers. Let's kind of look at them. I plugged these into Desmos. So first up, just tangent of 7 pi eighths is approximately negative 0.414. Our last two problems that we got were really the same thing. They're just commutes of each other. A plus B is B plus A. So that's what's happening here. They're just commutes. If you notice, this is, if I was to plug in just negative square root of 2, I would have a negative 1.414. That is, you should recognize 1.414 as a decimal approximation for square root of 2. So that's why this is happening. It's the negative version, but then 1 up. So this thing's kind of crazy, but it is, in fact, equal to these others. There's no need to further simplify. If you got this answer and said that was the final answer, great. They all equal each other. They're just written differently. So in review, we noticed we saw that several times you could do common denominators, or you could multiply by fancy ones. We saw that then we also could just do keep, change, flip if we wanted to, and then distribute. And there's also about unadding our fractions. That's also a tool. We also reviewed about conjugates and multiplying our conjugates and how that helps us rationalize our denominators using those conjugates. So hopefully this video helped you sharpen up your algebraic manipulation skills, gave you a few more tools in your toolkit to keep yourself sharp. These tools, I promise, are going to be invaluable right now in this course, and if you continue to move on into calculus, knowing how to simplify and manipulate these fractions and square roots are going to be very essential for you to know. All right? Take care, and we'll see you in the next one.